Okay, problem number 10 is a little bit of a challenge problem because it's not really like the problems directly related to the problems that we've discussed so far. We can figure it out. Let's get to work. If we're going to talk about raised to infinity, we're going to talk about how quickly these graphs increase as x gets continually large. In other words, as x approaches infinity. Let's think of a few things here. F of x equals log base 2 of x. Well, this is a logarithmic function, so we know what the graph of a logarithmic function looks like. Like so, it's increasing forever, crossing the x-axis at 1, 0. Now g to the x, I'm sorry, not g to the x, g of x equals x to the x power. We don't know what that looks like when it's graphed, but we'll come back and discuss that one a little bit later. H of x is x squared. Well, we know that this is a quadratic function, which makes a parabola when graphed. So you see as x goes to the right, as x gets larger, y increases quickly and quickly. And there's k of x equals 2 to the x power. And we all know that this is an exponential function, and we should know what exponential graphs look like. It'll increase like so, to the y-axis at 0, 1. Now the question is, which one of these is going the fastest, which one's the slowest? So let's just start with the three that we know about, and then we'll throw g of x into the answer at the end. Okay, comparing a logarithm function with a x squared. It's obvious both of these functions increase as x goes to the right, but h of x increases faster than f of x. So if you're going to put these in orders from fastest increase to slowest, h of x will be faster than f of x. Now let's compare the quadratic with the exponential. As x goes to the right, as x gets bigger, let's think of something like 10 billion. What's going to be a larger number? 10 billion squared or 2 to the 10 billionth power? While raising a huge exponent powers values, that's going to make us increase more rapidly. So k of x grows faster than h of x. This one will go first. Now we can all agree that having x raised to a power makes our function increase, and having 2 raised to the x power makes our function increase. So if you have x raised to the x power and x is getting large, think of 10 billion, we have something like 10 billion to the 10 billionth power. That's going to be ginormous. It's going to be the largest, and this function is going the fastest as x goes to the right towards infinity. So if we're putting these four functions in order from let me put the box around our answer. If we're putting these in order from the greatest rate of growth to the smallest rate of growth for large values of x, here we go. It goes g of x, then k of x, and h of x, then f of x. Hey, thanks for watching the video. Hopefully this was helpful.